Hello, everyone, and welcome. My name is Amy Brown, and I'm the Director of Events and Education for FacilitiesNet, including Building Operating Management and Facility Maintenance Decision magazines. Thank you for joining us for today's webcast, Mitigating Property and Parking Lot Flooding. Our presenter today is Cara Sabatino, Director of Marketing for AQUALIS Storm Management. Cara is a stormwater inspector and has been responsible for all branding and services and communication. She has 10 years of experience in marketing, communication, and sales within the service industry. Just a little information, today's learning objectives include reviewing responsibilities implemented by the Clean Water Act and recognize regulations across the nation on local, regional, and national levels. Understand the different stormwater components that assist in managing stormwater runoff. Assess real-life case studies where property flooding impacted businesses from poorly maintained stormwater systems. And evaluate the preventative measures that can be taken to ensure proper function of stormwater assets that reduce flooding and property damage. Before we get started with today's webcast, I'd like to just go over a few details. A live question and answer session will follow today's presentation. To submit your questions, please navigate to the Q&A button at the bottom of the screen and type in your question. Our presenter will answer as many questions as time permits. At the conclusion of today's webcast, you'll receive a PDF copy of today's presentation slides. You'll also receive a link to a brief online assessment. And upon successful completion of this assessment, you'll receive your CEU certification. Today's webcast will be archived at facilitiesnet.com/webcast. And with that, I'll turn it over to you, Cara.
Thank you, Amy. Well, hello and welcome to our webinar today. We're going to be talking about mitigating property and parking lot flooding. So during our session, we're going to discuss the impacts of improper management of stormwater assets that can lead to flooding, how to implement preventative management strategies, and of course, what your responsibilities as a facility manager or property owner are in ensuring proper water quality and quantity treatment on your property or properties. As Amy mentioned, my name is Cara Sabatino, Marketing Director at AQUALIS. I've been in the marketing and communications field for over 10 years and joined the AQUALIS team more than a year ago. And at the closing of our session, I'll tell you more about AQUALIS, but for a brief introduction, we are an environmental organization with focus in water management and support services for stormwater and lift station assets. And we provide comprehensive services from preventative maintenance to complete stormwater repairs, as well as provide ancillary services such as underground pipe inspections, vactor and jetting services, and engineering consultations. And we're also proud to service all of the US, including Puerto Rico. And as a reminder, here are our learning objectives for today. Since Amy has already gone through these, let's go ahead and get started. So in our first section, we're going to discuss the foundation for this presentation. Why is stormwater management so important? When we look at this illustration, we can see the contaminants and pollution that is picked up from stormwater runoff. And when it rains or snow melts, that water is moved through impervious surfaces, which is hard surfaces that doesn't allow water to seep into the ground. So these are surfaces like parking lots and roadways, especially in urban development. So maintaining and managing stormwater runoff is an extreme concern due to the high surface area of developed infrastructure. And that includes materials like concrete and asphalt. With more impervious surface, that means larger amounts of runoff that must be directed to a source to eventually flow back into the local watersheds. So all that water, or what we call stormwater runoff, is funneled through to stormwater assets to impact water quality and water quantity. And without these systems, sediment, trash, pesticides, car oil is all deposited to and into stormwater runoff. And that's then directed down into these stormwater assets and then slowly filtered out into local lakes and rivers, oceans, bays, any body of water. And where communities and ecosystems, they drink and use this water for recreational purposes. And if these systems are not designed or maintained properly, people, animals, communities can get sick. And these systems protect wetlands and aquatic ecosystems and improve the quality of receiving water bodies, protect the public health, and for our purposes today, also offer flood control. So you're going to hear BMP or SCM reference when we're talking about stormwater infrastructure. So BMP is best management practice and SCM is stormwater control measures. And these are engineered treatment measures, techniques, or structural control that manage quantity and improve the quality of stormwater runoff. And some systems are designed to manage more quantity than quality and vice versa. But the majority of systems aim to treat in the quality and quantity of the stormwater runoff. And in the upcoming slides, we're going to walk through the different types of assets commonly found on retail, commercial, real estate, residential, industrial, educational, healthcare, aviation, you get the point. All these types of properties utilize stormwater assets to mitigate flooding and ensure property safety, which reduces liability and ensures environmental stewardship. We're going to talk more about those requirements and responsibilities in the upcoming slides. So when addressing stormwater control measures, we're talking about systems like bioretention gardens, or bioretention rain gardens, sand filters, constructed wetlands, wet and dry detention basins are also known as detention ponds, grass swales, permeable pavement, level spreaders, property system, proprietary systems like filters, and all these systems make up engineered best management practices for stormwater control measures. And later we're going to dive into further into the common systems that you would find on your property, but next we're going to talk about the Clean Water Act and the national regulations that drive these local and state compliance measures. So we've talked about the impacts of the Clean Water Act and how the Environmental Protection Agency regulates water, and this is just a brief history and how we got there. So the Clean Water Act was initially passed in 1972 after public concern for water quality and safety after the Kahua River burning in 1969, resulting in the Clean Water Act, the Great Lakes Water Quality Agreement, and the creation of the Federal Environmental Protection Agency. And the Clean Water Act serves as the basic criteria by which the EPA regulates discharges of pollutants into the water supply. And the Clean Water Act has evolved over the years with the 2000 Phase 2 of the Clean Water Act, previously only applied to discharges from sites of 5 acres or more. And Phase 2, however, now applies to all construction activities distributing between 1 and 5 acres. And to reduce the impact of urban runoff, the EPA requires state and municipal agencies to implement, monitor, and enforce resident stormwater management programs. And these programs are designed to compel local property owners to maintain properly functioning stormwater systems. And regulations generally apply to residential and commercial properties that occupy a space equal to or greater than that 1 acre. And this includes your roof and parking lot. And although the EPA provides guidelines for state and municipal program requirements, program variations arise between geographies due to local needs and capabilities. And these variations in local compliance programs make it difficult for national property owners to implement universally compliant stormwater programs. And along with regulations comes consequence. And when these standards are not met, which include costly fines at the local level, and by the EPA, like in extreme cases like the Churchill Downs horse racing of last year, where they were found to be discharging unauthorized wastewater to New Orleans, which resulted in an over $2 million, nearly $3 million civil penalty. The stormwater control measures help to manage water quality and water quantity of post-construction stormwater runoff. And why does water quality matter? When we go back to our original illustration, water fuels our daily lives, from consumption to recreation. We need water to live and thrive and for our ecosystems to thrive. Protecting the quality of stormwater runoff from impervious surfaces protects our future and the next generation's future. And so what about water quantity? We can't function when our infrastructure is underwater, and systems are designed to handle 100-year storms. These systems are designed to hold and slowly filter the water out to the watershed to mitigate that flooding when properly maintained. So we talk about quality, water quality, these items that greatly impact the pollutants and the contaminants in stormwater runoff. So trash and debris, they negatively impact living organisms, their breeding ground for mosquitoes, and organic matter decay also reduces oxygen in the water column and can change the pH levels, which negatively impact living organisms that can be highly sensitive to any pH changes. This also includes gross solids, plant leaf matter. These are all things that we don't want to get into our water system. Nutrients. Overloading causes excessive weed algae growth and reduces dissolved oxygen levels in water bodies. Treatment options for algae and weeds is necessary to not only keep the system functioning as designed, but also to keep the water quality at an acceptable level. So phosphorus, which is commonly found in agricultural fertilizers and manure, and important to plant life, but too much in water can also lead to a reduction in dissolved oxygen in rivers and lakes. And sediment. So this carries nutrients, clogs gills of fish, can suffocate stream bed organisms. It limits aquatic food supply by preventing sunlight, which then limits plant growth, and it heats the water, which decreases dissolved oxygen levels even more. Heavy metals, so this is poison or damage processes of living organisms, exist in the environment for a really long time. This is motor oil, fuel, this is from vehicle wear use and human activity. When we're thinking of a parking lot, when it rains, that runoff collects those oils and heavy metals and deposits that right into the stormwater assets and eventually reaching the local watershed. Bacteria, so this can cause illness, comes from animal waste and sewage and all things we obviously do not want to reach our water system. Chemicals, so this is toxic to our living organisms. This includes pesticides or herbicides, sewage, paint, detergents, parking lots, loading docks, retail locations. These are common items that we find on the property. We had an instance where a detention pond was very white and murky, and come to find out that there was painting occurring on the property. When it rained, recently that paint all washed into the pond. So these are all things we want to try to control when we're talking about SCMs. So now when we're talking about water quantity, and for today's purpose, really our main focus. So we think of water quantity, we think of flooding, but what contributes to that flooding? So it's more than just heavy rain events and localized flooding. Impacts really do span much greater than that. So flood prevention, our main objective for today, stormwater assets help to mitigate flooding in parking lots, private and public property, including roadways. This flooding impacts the quality of the water as well, as we just mentioned in that last slide. And when systems flood, they don't function as designed, increasing the risk of contaminated water as the system isn't slowing or filtrating and treating the water. Waterway health. So having flooding impacts waterway health with destabilization of stream channels, damages to aquatic habitats, groundwater reduction. So this prevents groundwater recharge, which is the natural infiltration of water into soils. And this helps slowly moving down the water into the water table, removing those pollutants. And large amounts of water are not designed to impact regions, move that water across the surface more quickly, reducing that chance for that groundwater recharge, which helps remove those pollutants as it moves through the soil. Erosion, so this is flooding, which leads to sinkholes, soil destabilization, which can lead to much major public safety risks and also can impact stream banks. Sewer overflows, a common occurrence during flooding when backup pumps or systems fail to handle the amount of water, leading to untreated wastewater reaching local rivers and lakes that can make people and organisms sick. So in addition to regulations, making our world a better place, I think, is something that most of us, if not everyone, can probably get behind. So establishing environmental stewardship through stormwater management programs makes businesses and organizations accountable for contributing to assisting our waterways. So stormwater credit programs, these are established to incentivize when compliance and stormwater management is upheld. And this varies on the municipality, but this is always worthy of investigation. And if you can receive a return on your investment in the management of your stormwater assets, it's definitely something that you want to explore. Community investment. So this can include grants and partnerships when investing in stormwater management, community involvement, showing your clients, customers, or team members your investment in making a difference in the community's watershed. And if your property allows for green space accessibility, this can be used on properties for recreation, for employees, clients, for customers. Environmental success, as we've established, this promotes wildlife health, community health, protects the community and the established habitat. It's also an opportunity for making a difference. So the ability to use for public relations, establishing your brand, as making a difference in the community and meeting corporate responsibilities. So we've established the why when it comes to managing stormwater, but what are the responsibilities of property owners or those that assist owners in managing their properties? So there are two major facets to property owner responsibilities. We're talking about inspections and operations and maintenance plans, and most commonly referred to as O&M agreements. So inspections, this includes notice of termination, like pre-occupancy inspections or pre-NOT inspections. These take place between the construction phase of the system and the post-construction operation of the site. Any maintenance or repair needs are documented for the general contractor to perform before the property owner becomes responsible. And annual inspections ensure that a stormwater system continues to function as designed and is in compliance with federal, state, and local regulations. And every facet of the system is examined. And an action plan can be developed for any system that has been improperly maintained or requires rehabilitative or restorative repairs. An annual inspection report is typically submitted to the regulatory body. And sometimes inspections may require certification by a professional engineer or a qualified personnel. So it's important to check with your municipality on requirements or work with a stormwater management team that can assess the requirements and process all that paperwork and documentation in coordination with the local regulatory body. Operations and maintenance, O&M plans, are typically established during construction and on file with local municipalities to ensure compliance. So this typically includes a maintenance schedule, inspection requirements, frequency of inspections, which is typically yearly, easements or conveyance for maintenance, and a description of maintenance like mowing, treating vegetation, debris and sediment removal, inlet and outlet cleaning. Your O&M agreement is really your greatest tool in ensuring you are meeting compliance standards. So this takes any mystery into understanding what your responsibilities are for your stormwater assets. And really, depending on the age of your system, this can be found on file with your local municipality or working with a stormwater management team to help facilitate that document and come up with a management plan that works best for you, your budget needs, and your system needs. So notices of violation. So this is an official notification to inform of a non-compliant property owner, manager of a violation in relation to a stormwater management. So when inspections or O&M agreements are not being followed, this is when a notices of violations can be issued. So it's a very detailed document that includes where the deficiency was detected, when and how it should be fixed. This may include fines and penalties. And these fines are outlined in the NOV documentation, and typically a deadline is enforced. And if no action or communication with the regulatory body occurs, you could be facing daily fines of hundreds of thousands of dollars each day until there's a remedy. So most importantly, in every facet of life, ignorance of environmental laws is not an excuse for non-compliance. So even if you are unaware of your responsibility, it is necessary to take action if you receive a notice of violation. So it's important to take the steps that we're providing to you today to ensure that you avoid any costly fines in the future or know how to act if you get a notice of violation. It's worthy to note that regulatory bodies don't want to issue fines. Their responsibility is to uphold the environmental standards, and they want to work with property owners in maintaining their systems to avoid fines at all costs. So it's essential to respond and work with the regulatory body to let them know you have a plan in place. We manage all communications and approvals with municipalities to ensure compliance and to hopefully reduce fines. In many cases, as long as that communication is open and a plan is in place before the deadline, municipalities are willing to work with property owners and come together to make the community better. And so just a brief reminder of the basics of stormwater management. These systems are designed to manage rainfall. They're agreed upon and approved by a regulatory body, and they should be inspected or maintained at a minimum annually or per that O&M agreement, like we talked about in the last slide. So what leads to notices of violations? So there are many factors and incidences that can warrant a notice of violation to be issued. So during construction, they have their own sets of standards, and since the impacts to water quality and quantity are much different than with post-construction. So it's the failure to apply for the MPDS permit coverage, failure to prepare and implement a stormwater pollution prevention plan, which we refer to as a SWIP, inadequate SWIP or BMPs, or exceedance of permit effluent limits. After construction, what we as an organization focus on, and our focus for today, is after construction or post-construction violations. So failure to implement appropriate stormwater control measures, failure to maintain or repair SCMs. So this is a big one, especially with an established O&M agreement on file that literally lays out your responsibilities. This can especially be brought to attention of the municipality when water is pooling or flooding in your parking lot or property. So it's an easy way to identify that a system hasn't been maintained. The failure to conduct or document inspections. So many times annual inspections are required at a minimum and kept on file with that regulatory body. Illegal dumping and discharge and illicit connection. So connecting to a sanitary sewage system into a stormwater system. So we understand the responsibilities. Let's talk about how we can mitigate flooding utilizing SCMs and what preventive maintenance protocols should be applied and what deficiencies can end up causing flooding by each type of common SCM that you can find on a property or in a parking lot. So I want to highlight briefly the relevant news articles about flooding due to stormwater assets. We typically see flooding associated with these hurricanes and strong rain events, but important to remember that there usually is a source for why that flooding or backup occurred. And take the flooding at the state capitol in Texas. This was due to a single clogged storm pipe causing nearly an inch of water in the wings of the capitol, shutting down the capitol for a few days. And the middle shows a police cruiser sinking into flooded waters at a grocery store that has a history of flooding. And the last headline is from Tropical Storm Elsa from this past summer. So this shows a before and after of where a clogged drain caused water to pool and back up on the streets of New York due to trash. So solutions are simple, and there's always a root cause coming back to that flooding. So let's break down the anatomy of a parking lot when looking at the most common assets on a typical commercial or retail property. So bioswales, they're typically located on the border of a street or impervious surface like a parking lot. And these systems are vegetated swales, aesthetically pleasing, made of layers of soil, mulch, and gravel, and can manage large amounts of runoff and slowly infiltrate into the soil. And when larger rain events occur, a drain is designed there to carry that water through to an underground pipe that feeds out into another treatment system. Catch basins, a very common facet of any parking lot. They collect runoff to then distribute down into an underground system to feed back into the waterway. Retention pond, an SCM that collects and retains water that is filtered from the bioswale, catch basin, or from loading docks. Loading docks. So this is an area particular to flooding, and we're going to talk about the systems that are commonly found on this part of a property. Impermeable pavement. So this is concrete pavers or asphalt that's designed to infiltrate the water to absorb that runoff. Many of these systems work in harmony together to ensure the proper mitigation of water quantity and, of course, water quality. If you have a backup or a clog at the inlet, the part of the illustration coming, which is part of the illustration coming down off the parking lot, or the outlet where the water is feeding out to the community water source, like a lake or river or bay, the water will back up to the catch basin, back into the permeable pavement, into the loading dock. So understanding how that system works together can help in an emergency situation to find that root cause. So catch basins. A common solution in stormwater asset is designed to collect stormwater runoff from non-permeable surfaces and very effective stormwater solutions. These come in few different designs, including drop inlets. So that's that second photo from the bottom left. Curb inlet, which is that middle photo, and a catch basin, which is the second photo from the right. These systems take the flow of water underground through pipes, eventually to a pond or watershed. And sediment is settled to the bottom of the catch basin, not typically meant to reach the drainage system. However, it's not designed to properly promote sediment settling as other stormwater assets like ponds are designed. However, as sediment and trash becomes accumulated, this can further cause backups and flooding to the system. These are usually found in parking lots and roadways, and normal wear and tear is expected as these systems are the first line of stormwater defense in parking lots. So why do catch basins fail? Common deficiencies we see with catch basins include brick and mortar deterioration, so found in or around the mortar of the basin. With proper management teams, we can monitor over time if deterioration requires any kind of intervention. Sinkholes, so this occurs when water infiltrates outside of the basin through the deterioration of the mortar, causing the water to pool outside and then eventually cause a concave that then appears above ground. So these are very dangerous and need to be addressed immediately. Sediment buildup, sediment can collect at the bottom of the catch basin, then causing further blockage and backups, ground separation and cracking around the catch basin. And specifically, we're talking deficiencies that can lead to flooding. So with catch basins in the name, they're designed to catch debris and trash, but if not regularly maintained or clear, the catch basin will back up or that debris will then continue through the system to cause further blockages. There's nothing worse than flooding caused by trash accumulation, which is such a simple and effective preventative maintenance treatment. Blockage further in the drain system. So looking back at our illustration, if there's a blockage, crack, or issue with the underground pipe, that water could flood back up into that catch basin. Heavy rainfall, so simple, just as an overwhelming amount of rain can cause pooling, but if water's not drawn down quickly, that's when you know you have an issue. So looking into preventative maintenance steps before heavy rainstorm can assist in assuring the proper flood management. Preventative maintenance, so visual inspections, looking at the brick and mortar for deficiencies like sinkholes and completing annual inspections. Sediment measurement, so using a tool, so this is dropped into the water to measure the sediment level over time to evaluate if there's any further corrective maintenance needed. Trash and debris removal, simply just removing and fishing out those floatables to make sure they don't further clog the system on a regular basis or when there is a heavy rain event approaching. Documentation of any deficiencies for monitoring, so keeping a record of repairs and maintenance, especially if applicable to your O&M agreement. And corrective maintenance, so vactor, high pressure vacuum trucks to remove sediment and sludge, jetting high pressured water that can clean and dislodges large items, underground CCTV pipe inspection. So this can help to detect any further damages, clogs, and root cause analysis. So if you have frequent flooding, you can diagnose the problem instead of putting a Band-Aid on the issue. extensive trash removal. So the system has been neglected over time. An extensive clean out would be necessary here too. And repairs to the structure, so rehabilitation or restorative repairs can also happen with full replacement eventually needed over time. And improvements are always being made to materials to extend the life cycle of these assets. Permeable pavement. So permeable pavement is an SCM that consists of paved surfaces that reduce runoff with infiltration. So the great thing about permeable pavers is you don't need to sacrifice surface area, as it can be used as an alternative to traditional pavement. So there are many variations as well, and some include aggregate materials that are used to help absorb the water and assist in groundwater recharge. And these not only helps the water quantity, but also with water quality. And typical options include porous asphalt, pervious concrete, interlock pavers, plastic grid pavers. We're going to explore a case study actually later that includes some pavers and flooding that was due to inadequate maintenance. And quality and quantity treatment. So removes pollutants, helps to assist with water quality, infiltration to reduce quantity, so that drawdown is dependent on manufacturer guidelines and site conditions. So with so many variations of permeable pavement, following manufacturer guidelines for preventative maintenance and corrective maintenance is necessary to ensure the longevity of these systems. And these are really beneficial in urban development and retrofits. So where surface area is lacking, it's a great solution for existing parking lots when maintained properly. It's also a great solution to assist in mitigating flooding. But what happens when they fail? So common deficiencies, that aggregate material clogging. So when sediment settles into the material, this can cause a crusting that can lead to flooding and inadequate filtration that could cause pooling in specific areas. Plow or vehicle damages. So common to these systems, blades from snow plows can damage the assets. So protective blades are needed on snow plows when cleaning these areas during the winter weather. Anti-icing, pre-treatments, deterioration. Salt should never be used on permeable pavement, as this erodes the aggregate material and can also add to that sediment collection. Flooding. Sediment accumulation. So settling into the joints of the pavers will cause backups and flooding when proper preventive maintenance is not followed. Clogging from winter sanding. So that de-icing sediment can also clog the system, block infiltration, and then the water will pool above. Overflow from other SCMs. So permeable pavement is not designed as an overflow from other SCMs to help infiltration. Heavy rainfall, a common factor through all of our SCMs. With heavy rainfall and inadequate preventive maintenance, flooding is bound to happen. So preventive maintenance, visual inspection. So this can typically be done on a routine basis to ensure that if there is aggregate material, it's still plentiful. Percolation testing. So this is done by testing portions of the pavement and then timing that drawdown depending on the manufacturer. The timing really indicates if there's an issue. Spot aggregate material replacement, routine industrial vacuum. So using the high power vacuum to remove buildup of sediment. Maintenance documentation and recording, especially important to continue documentation, especially if there's a warranty that includes preventive maintenance. And these different assets will include a full detail of what preventative maintenance is needed for these systems. Corrective maintenance. Oftentimes, corrective maintenance is needed to get the system back to its original function. So this includes a deep cleaning with an industrial vacuum, aggregate material replacement in large scale, and then paver replacement if damaged as well. As a full-scale replacement, the system has been neglected, and corrective maintenance will not get the system back to functionality. The retention and detention ponds are another common form of SCMs that you see on many types of properties. These systems are highly successful in treatment of water quality and quantity. So retention ponds are designed to always hold a permanent volume of water, and detention ponds are designed to hold a temporary volume of water during and immediately after rain events. So retention and detention ponds are typically found in urban and residential areas with large amounts of impervious surfaces, such as shopping centers, apartment complexes, parks, and other large paved areas. And stormwater ponds are designed to accept and store stormwater during high water events. This increases the overall flood storage of a system and reduces damages caused by flooding by retaining stormwater long enough to reduce the peak flow downstream. And water is diverted to a wet detention pond by a network of underground pipes connecting storm drains to the pond. The pond's natural processes then work to remove pollutants. So the system allows for large amounts of water to enter the pond, and the outlet then empties those controlled amounts of water to a downstream water body. And through our maintenance programs, we monitor, provide inspections, and alert property owners to any deficiencies that impact these ponds. So common deficiencies found in stormwater ponds. Vegetation overgrowth. This is very common sign of neglect of the system is overgrowth which hinders the pond from functionality, root systems, impacting slope, encouraging mosquito habitats, and is ultimately unsafe for passerbys as sight lines are impacted, and is a common note for notices of violations. Nuisance vegetation. So nuisance vegetation can quickly take over, impacting the natural infiltration and pollutant removal. Sinkholes, common when underground piping leading to the pond is damaged, causing that concave above surface, revealing that sinkhole. Again, so important, and to have these addressed immediately. Sinkholes are extremely dangerous. Erosion, if water bypasses the system or parking lot is overflowing, erosion can occur when water is displaced and moving over a slope rapidly. And flooding. So this can occur due to sediment accumulation. So in addition to mitigating flooding, another important function of stormwater ponds is to capture and trap debris and sediment. When sediment gets too high, it can impact the quality of the water and cause blockages to the outlet. Trash accumulation. So some ponds even include trash racks to further decrease the accumulation of trash. So collecting the trash at the inlet and near the outlet to help decrease trash that can clog or reach the local waterways is really important to help prevent that flooding. Debris or clogs in the outlet structure, so trash, sediment, all contributing factors here. Failure to maintain structures. When ponds are neglected, water levels will rise past the design levels, which can then result in notices of violation and flooding. Collapsed pipes. So underground structures feed into the ponds, and if they collapse, backups are going to occur, whether in the pond or backups are going to occur back into your treatment train, whether it's the catch basin or bioswale. And then heavy rainfall. That drawdown is not occurring at the rate it's supposed to. So it's important to watch that drawdown, especially after a big rain events. Preventative maintenance. So vegetation management. So we just talked about how that vegetation can get out of hand quickly. Routine mowing, trimming, and removal of nuisance vegetation is really important here. Monitoring sediment in the forebay or basin, removing that trash and debris, monitoring water levels after rainstorms for proper drainage, assess animal activity. So beavers really love to make homes in these ponds. They create dams that then can cause flooding and backups, prohibiting the function of the design of the pond. Corrective maintenance. So excessive vegetation removal, slope stability to reduce or repair erosion, clogged or damaged pipes. So sometimes extensive repairs if major excavation is needed. CCTV underground inspections. So cost-efficient way to find root causes issues to treat the issue at the source. Swales and bioswales. So bioswales and grass swales are SCMs that are full of vegetation or grass that border impervious surfaces. So as you can see in these pictures, they're very much always located near parking lots, and they utilize infiltration to reduce flooding and collect pollutants. So unlike rain gardens, these systems consist of layers of materials to help the water infiltrate into the soils, and with peak water levels diverge into an underground pipe. These systems are linear in nature and function as an open channel to help convey that stormwater runoff. And they're designed to help mitigate a portion of stormwater runoff and very aesthetically pleasing addition to roadways and parking lots. These systems also assist in reducing the runoff velocity to capture large particles and pollutants during rain events, and they assist in lessening erosion in areas they are designed, and they're typically part of a stormwater treatment trains as they are part of multiple SCM systems on a property. What happens when they fail? So common deficiencies, the vegetation overgrowth, you're going to see it over and over again. To the point where that vegetation is too overgrown that it can no longer properly manage stormwater as it's designed. Nuisance vegetation, like with stormwater ponds, here too can grow in thick patches, hinders the water from flowing freely or as designed. Erosion, if water's not directed or the system's not maintained as they're designed, erosion can occur if the water is bypassing through an area that's not part of the stormwater asset. Sediment accumulation, so over time, sediment will build up in the system, which will impede the infiltration of the system, eventually causing a slow drawdown and flooding of the bioswale. And flooding, so improper maintenance, number one, always can root it back to that. Trash and sediment accumulation, if not properly maintained, trash can build up and hinder that runoff from ever reaching that soil it's meant to infiltrate. Non-maintained soil, so these systems, like I said, are designed with layers of compact soil, loose mulch, gravel, all which must be maintained to properly function as designed. Failing vegetation, so if the vegetation fails or just dies, it's not assisting in reducing that velocity and ultimately overwhelming the swale to cause flooding, as well as not providing any pollutant uptake. Backups from SCM treatment train, since these systems capture some runoff on properties, when other SCMs fail, it can then overwhelm the bioswale. Heavy rainfall, continuous rain, high velocity, all can contribute to flooding if the swale is not properly maintained. The swales and bioswales will slowly degrade naturally just due to their design, and where water at high velocity will eventually drain, causing vegetation and soil to deteriorate, which decreases the effectiveness of that infiltration. So extreme rain or flooding can only exacerbate the soil degradation and failure of vegetation to thrive, which then increases that flooding. And then clogging, so from that sediment to that debris. Preventive maintenance, so vegetation management, so important here. Reseeding or replanting is needed to help encourage that proper growth to avoid vegetation failure. Soil inspection, ensuring proper compaction and infiltration testing. And monitor water levels after rainstorms. So especially after newly constructed systems, analyzing these systems while or just after a rainstorm is really important to make sure that they're functioning as designed. Corrective maintenance. So excessive vegetation removal, slope stability, if there's slope failure, this impacts the velocity in which that runoff reaches the system, causing additional sediment to infiltrate the system and early failure. Sediment removal, heavy sediment is visual and suspected. This can be excavated from the system and disposed of. Soil rehabilitation, so this may require a full rehabilitation to restore the soils to the original design and regain the infiltration and removal. So underground systems. So engineered underground SCMs offer flood control, reduced erosion, and groundwater recharge. So by slowly moving stormwater runoff to areas with densely impervious surfaces, this solution can move water to slowly reintroduce to the watershed. So large pipe systems help slow down and hold stormwater runoff, commonly paired with proprietary devices so that water quality can also be treated. Underground assets assist in the removal of hydrocarbon, phosphorus, and other heavy metals when coupled with proprietary devices. These are typically installed in parking lots, streets, and open spaces, provide additional public safety as well. And then proprietary devices are used in conjunction with underground SCMs in the form of filters or cartridges to further remove pollutants through different kinds of systems. And underground systems maximize the space below ground to minimize the impacts to land above ground. So what happens when they fail? So sinkholes, like you can see in this picture here, water escapes pipe and flows over the rock structures, eroding cavities, eventually the collapse to form these sinkholes. Erosion, joint fractures where the pipe joins or connects is under pressure. This can easily fault to cause further damage that typically is only noticed until above ground from a sinkhole or flooding. Fractures, overcompaction, or weight can cause fractures, as well as aging infrastructure and eroding corrugated metal pipes, blown out slopes. When we're looking at flooding, this includes, again, back to improper maintenance, including failures to complete visual or annual inspections, clogged drains, debris, trash, sediment, all settle and clog these systems to then back up into catch basins and onto your property. Water bypass, so when that water detours from the design. Damaged pipes, so similar to the above, water's not reaching or moving through its intended path, backing up to cause above ground flooding. Sedimentation accumulation, trash and debris blockages, all leading to flooding. So preventive maintenance, what can you do to mitigate that flooding? Sediment measurements, so using a proprietary measuring tool to monitor sediment over time in the system, visual inspections, removal of floatable trash and debris, proprietary device inspection and cleaning, and corrective maintenance. So vactor, jetting, CCTV underground pipe inspections, proprietary filter replacements. So these can all vary in types and sizes and quantities as well. So working with the stormwater management team that understands those filters is really important. Repairs and rehabilitation. So repairs to underground systems are usually costly and extensive. So with aging infrastructure, many systems installed 30 years ago are now reaching their life cycle. So utilizing CCTV underground inspections can assist in evaluating the health of the system in order to budget appropriately for repairs and replacement. So loading docks. So these are designed with multiple types of SCMs in order to help manage water quantity and mitigate flooding. So we receive notices of flooding so often in this area of a parking lot that we really wanted to highlight the issues with loading docks. Trench drains, these are standard assets for this area. They provide a linear and long-reaching drains in order to drain water quickly and help this area stay dry to receive trucks. So you can see that on the photo of the one from the second to the left. And then some pumps are also located in this area to help move water where gravity is unable to move it down through the underground system. So these pumps can fail due to the lack of maintenance and neglect, causing further flooding. And catch basins are used in this area to move the water to underground systems by catching debris and trash. And these systems, due purely to the location, are under constant wear and tear from the amount of debris like broken pieces of pallets, spilled materials, and trash. When loading docks fail, so this includes debris accumulation, clogging, sediment buildup, and trash can clog the pump, the trench drains, and catch basins, run to fail pumps. So this is very common in pumps in the run to fail method. Flooding, improper maintenance, or neglect of the system. So these areas require frequent visits to ensure systems are functioning as designed, especially in locations that rely on deliveries, clogged drains, backups from that treatment train that we talked about, debris and trash buildup. So preventive maintenance. So this is sedimentation measurements, visual inspections, especially during rain events, ensuring that the water is moving where it needs to be necessary and that drawdown is happening correctly as well. Removable of floatable trash and debris, proprietary device inspection and cleaning, corrective maintenance. So we're looking at vactor, jetting, CCTV underground pipe inspections, filter replacements, and repairs and rehabilitation. So this includes pumps as well. So full replacement of pumps may be required if they are not maintained and require frequent emergency visits. The run to fail method. So I mentioned this briefly. Run to fail is a common practice with these systems. So they're typically tucked behind buildings, hidden parking lots, vegetated. So if you're unaware of what Bioswale is, you would think it was there to be designed as an aesthetic part of a parking lot. It's actually a system that requires maintenance. So we find that this is due to lack of awareness of these systems, poorly maintained due to turnover in positions, unaware of property use O&M agreements, deficient knowledge of regulations. Sometimes there's budgetary restrictions, can be typical, especially with systems that require extensive restorations. Lacking proper budget allocation to maintenance. So we can't emphasize this enough. With proper preventative maintenance, you can save on costly emergency visits that only treat the issue, not ensure the system is brought back to proper design and function. So we love to use this graph. It's depicted, you can invest in your system through preventative maintenance. Your system is going to retain functionality, mitigate flooding, and manage water quality and quantity as it's intended to. And over the term of the life of your system, preventative maintenance is routinely much lower than the cost to repair and bring a system back to compliance. So we've got a couple case studies, and we're close to the end, and we'll get to Q&A very shortly. So this is a case study. AQUALIS was on site for a regular scheduled maintenance inspection visit, and a field tech reported that the dock area was not draining properly. So it appeared to be draining, but extremely slow. Crews tried to remove debris from discharge pipe and clean out, but were unsuccessful. So the pooling of water would occur during rain events, causing dangerous conditions for workers. So the solution was to install a 4-inch trash pump to dewater that area so the vac and jetting services could dislodge any large debris, sediment, or sludge. And then this happened to be something that our techs found in the field before a larger rain event could have flooded this region. So even with routine maintenance, flooding can still occur, but with the right team continuously documenting, monitoring, and reviewing the site, you can easily detect when something's amiss and needs to be addressed before a major flooding event can occur. This next location is in Mount Dora, Florida. So these were items noted during a recent inspection to the stormwater facility. The site had multiple areas of permeable pavement that had become clogged and damaged, and they were exposed and broken. Reinforced sod grid was visible throughout the pervious parking areas. So sod grid is a type of permeable system used for parking as an alternative to asphalt or concrete. It also provides support and traction for vehicles to park and for people to walk upon. So the damaged sod grid was preventing water from properly flowing through the stormwater system. To repair these issues, the damaged pervious pavement needs to be excavated and removed, and that new sod grid installed. You can see the site was in complete disarray. It was not functioning as intended, sediment was accumulated, and prohibiting any sort of infiltration. The solution included excavating and removing all damaged portions of the grid, restoring and replacing the grid, and then finally reseeding and restore the pervious pavement function. So the photos here on the bottom are mid-project, but these grids are then filled with the soil on site to encourage that infiltration. So this location in Dallas, Texas was experiencing frequent flooding. So AQUALIS was engaged to assist the client in looking into the cause of the routine flooding. It was reported from the store that this area is always slow to drain after a rain event. And after further investigation, it was found that the nearby catch basin takes on a lot of trash. And during those rain events, the trash debris clogs the drain. So it was determined that the amount of trash was being carried from the neighboring property to the catch basin. So no amount of preventative maintenance on site would be able to prevent that trash from washing down into the client's property. So they needed to excavate, hand shovel to get everything back to compliance. So additionally, the site above the catch basin needs to be stabilized because of erosion from that trash washing down. Eventually, the team then also installed a silt fence to prevent large trash and debris from traveling across property lines. So sometimes even with proper maintenance and inspection, the root cause can be at your hands. right? So it's important to be mindful of stormwater consequences for your property and your neighbors. Spreading education, informing others of how to be good stewards of stormwater management is essential to preventing flooding. So stormwater runoff disregards property lines. So work with your neighbors to ensure all compliance is met, which helps mitigate flooding and impacts water quality for all. So how can AQUALIS help with flooding on your property? So we are the leading nationwide provider of stormwater and lift station management services. This includes preventive maintenance, corrective maintenance, retrofit, redesign, as well as emergency response. So we help protect assets, mitigate notices of violation, diminish flood risk, and support your efforts in environmental stewardship. So we service single site and multi-state organizations through our preventative maintenance programs. So as a leader in stormwater and lift station management, we're pleased to partner with and educate property owners on the importance of preventive maintenance and compliance. So with our programs, we help building owners and facility managers avoid costly violations, reduce liability, improve system performance, and increase overall property safety. So we're a team that prides ourselves in safety, compliance, and education, highly specialized in the field, from stormwater inspectors to certified small space training. And many of these certifications include routine and continuing education for renewal to ensure that we are following the most up-to-date regulations and processes. So today I've got Michael Youngblood, professional engineer and water planning engineer at AQUALIS. He's going to help join us. I think we have a few more minutes left for question and answers. And Michael has over 15 years of experience in the environmental remediation, water resources, and regulatory compliance industry. So I'm going to turn it back to Amy to assist in moderating the question and answer portion of our session.
Yes, thank you very much, Kara. We appreciate all the information you provided. Just a reminder, you can type in your questions using the Q&A panel at the bottom of your screen. The first one that's come through, Michael, is, and Kara talked about this a little bit, but is a catch basin best, or is there an alternative best practice to proactively address sinkholes in asphalt paved parking lots that causes likely root spread from trees and water pooling, then getting down below the asphalt through cracks?
I think the question is not asking about sinkholes in relation to like the stormwater conveyance system, but just, you know, what would be the best stormwater BMP to remove stormwater from your parking lot area. So, I mean, the catch basin stormwater sewers is definitely, you know, very economical and the most basic of stormwater BMPs. But if you didn't want to utilize that, I mean, other ways would be to have a parking lot that would direct surface water runoff to maybe some like bioretention facilities on the outside of your parking lot area and things like that. But if we're strictly talking about sinkholes forming associated with catch basins or storm sewers, preventative maintenance is your best bet to proactively, minimize sinkholes from forming. So you really got to look at the subsurface. So that'd be opening up your catch basins and seeing if there's mortar deterioration, or doing any type of camera inspections within the storm sewer piping to see if there's, any avenues for that water seepage to migrate sediment to voids. That's what causes the sinkhole. So, if in the storm sewers piping, it'd be looking at deformations in the pipes or joint failures and things of that nature. So it's really just getting that subsurface and inspecting it.
Great, thank you. Another question, Michael, is how do you prepare systems for some of the increased rainfall and flash flooding we've been experiencing across the country lately?
I guess it's kind of two separate issues there. We are experiencing increased storms. You always kind of hear the term 25-year, 50-year, 100-year storms, and these are just statistical storms that are likely to occur within these time frames, but then you do have flash flooding, but that's kind of a separate issue there. So flash flooding is a bit more difficult to prepare for just because it's such high volumes of water in such short periods of time. So I won't say there's no way to prepare for them, but it's just, it's more of a difficult situation to plan for. It's just, you'd have to have such greatly, like just very over-designed stormwater systems, and that's just may not be feasible based on your site constraints or the property that you have, or it's just not economical. You know, if we're, but the best bet to help minimize damage caused by, you know, flash flooding and these increased storms is just to, you know, have the preventative maintenance. So your, you know, stormwater system is really, you know, operating at its optimized, you know, design. So, you know, you don't have clogging in it and things like that. Just that can exacerbate the problem with these such, you know, large storm events. And, you know, if it is a system that is experiencing difficulties, you know, that's where a stormwater professional can come into play and assess your system and see, you know, if there are options that you could pursue, such as like a retrofit on a system to see if you can, you know, kind of redesign it to, you know, increase capacity, or you could add other BMPs upstream, like for say, if you have a like your system is mainly treated by a detention basin, maybe there's ways to add smaller BMPs that are, you know, upstream of your treatment train. So like adding some like bio retention, you know, little cells within a parking lot area that can kind of help reduce the loading on that basin that you might have on your site.
Perfect. Another question, when is the best time to define maintenance responsibilities when there are several site improvements that impact storm management, whether it's pedestrian pavement, landscaping, irrigation, retaining walls, as well as vehicle pavements?
Just rereading the question here for a second.
Sure. When is the best time to define maintenance responsibilities when there's several site improvement projects that'll impact stormwater management, such as pedestrian pavement, landscaping, irrigation, retaining walls, as well as vehicle pavements?
I think you just, you know, if you're adding these type of improvements, hopefully you do have an O&M plan, and it's just, it would take the time to look at what's currently in place and see what these additions, how they could impact it. So again, you know, maybe discussing with the municipality or talking with a stormwater professional to see what recommendations they may have that you can implement at your site.
And Michael, I would assume along with defining the maintenance responsibilities, several of those improvements, you would also need to make sure that your stormwater management system is up to the level that is needed for some of these improvements. Is that correct?
Yeah, absolutely. I mean, if you're talking about increasing any type of impervious surface, and you do have a designed stormwater system, I mean, you definitely need a stormwater professional to be involved to make sure that system can handle any, you know, the increased runoff or peak rate flows that are directed towards it.
Perfect. I think we have time for one more question. Michael, I know a lot of people around, you know, standing water or large bodies of water, you know, are concerned about pests, whether it's mosquitoes or other type of insects or other type of animals. How would you combat, you know, some of the mosquito or pests around SCMs?
Well, yeah, as you said, I mean, mosquito breeding is really promoted by shallow, stagnant water. So if you are having issues with mosquitoes, it tends to be, you know, a sign of a larger issue with your BMP. So like if you have a detention basin that is, you know, they're designed to retain water for a short period of time, usually 24 to 72 hours. So if you're having mosquito issues with a detention basin, that means you probably have some type of clog in that system. Now, if we're talking like retention basins, which are designed to always have a permanent pool of water, sometimes they kind of promote nuisance vegetation like cattails. And other dense vegetation, and that promotes mosquito breeding as well. So it can be as simple as taking care of that nuisance vegetation, or sometimes you can add an aerator to a pond to help promote movement in the water. But again, you could have a stormwater professional come out and take a look and see what site-specific course of action that could be implemented at your site.
Perfect. Thank you very much. Michael or Kara, any final last words you'd like to provide for our audience?
I just want to say thanks for attending today, and we really appreciate your time, and thanks for staying on with us to help with the question and answers.
Wonderful. Well, thank you both for joining us today and the great information you provided, and thank you to AQUALIS for sponsoring this webcast. Again, you will receive a copy of the presentation of the PowerPoint slides, and then it will be archived on FacilitiesNet if you'd like to rewatch it. So check your email for that within the next 24 hours. And thank you again for joining us today, and have a wonderful day.